We spent last week talking about something that I am really, really bad at, and that's spelling. And so I thought it would be a nice refresher to spend this week talking about something that I'm kind of okay at. It's been mentioned here a couple of times, and I still have some other video ideas that I'm excited about creating around the subject of programming. But computer science is one of the few academic disciplines that I would rank myself as kind of okay at. I might even go as far as saying that I'm pretty good at it. But the question that I want to talk about today is, how did that happen? And it comes down to a question, I think, of nature versus nurture. For as long as I can remember, when people asked me about getting into the field of computer science, they wondered what prompted me. And the answer that I always gave was the same, which was it was kind of the only academic thing that I was any good at. And that answer, I think, is very nature centric, right? My thinking historically has always been that my dyslexic brain that can't spell my way out of a paper bag is really good at other things that computer scientists and programmers need to be good at. Decomposing algorithms, understanding how to apply abstract concepts to other abstract concepts, how to codify confusing and complicated things into a set of repeatable instructions, right? These are skills that I think a programmer needs to have to be good at programming. And I've always fancied myself as relatively good at those things. But I think that that answer neglects the other half of the equation, which is the nurture aspect. And I was born 1 month after IBM announced their first personal computer, the 5150. And so that placed me in kind of a unique part of history where computers were just making the transition from being calculators the size of warehouses to things you could actually have in your home. And to that point, my father was and continues to be a computer enthusiast, which meant that growing up, as long as I can remember, my father owned a personal computer. The first one he owned that I can remember is, I think, a Corona PPC 400, which was a portable computer with a tiny screen and a floppy drive, and it ran MS DOS. And my earliest memories of that computer were playing a game called Sopwith, which was a biplane type game where you flew back and forth along the screen. And it was a lot of fun, and it really kindled in me a fascination with computers. The fact that I could play with this thing was incredibly novel. And at the time, not something that a lot of people had exposure to necessarily. And just playing that game was an arduous experience because it wasn't like today where you take out your iPad and you tap on an icon and boom, you're playing Fruit Ninja. Instead, to play that game, I believe the steps were, and it's been like almost 40 years, so cut me some slack here, but I think that what I had to do was have the computer off, put in a 5 1/4 inch floppy with MS DOS on it, boot into an MS DOS prompt, take out the MS DOS floppy, the OS was at that point in memory, put in the Sopwith disk, switch over to the A drive, which was the drive designation for the floppy, and then run the Sopwith executable in order to play the game. And for me, at, I don't know, probably 7 or 8 years old, that was a pretty tricky series of events to have to get used to in order to get the thing that I wanted, which was play Sopwith. And so I think that that instilled in me an appreciation for some of the very fundamental aspects of how computers work. I was incredibly incentivized to want to do this thing. And so learning those steps and internalizing the mechanisms that enabled me to be able to do it was really critical to me getting the thing that I wanted. Also, a funny side note about Sopwith is I remember even as a kid, maybe like 4 or 5 years later, having a wave of nostalgia around playing Sopwith and putting it on what I think then was our home computer of 486. And Sopwith as a game didn't have any notion of timing, right? It updated every time the CPU clock cycle occurred. It would update the game and move you forward, say, 1 unit. And so as a result, when you played Sopwith on a 486, it played so blazingly fast that you would start it up and your plane would just instantly crash into the wall at the end of time. And so you couldn't really play it because there was no rate limiting that prevented the game from playing at incredible speeds. But that's a random aside. Although, even at the time, it did educate me about the way computers process instructions cyclically on a certain clock that's determined by its megahertz, etc. But again, these are just the little things that I have taken for granted that are very much only because they were nurtured inside of me. And that wasn't all, because as time went on, I had more access to computers, and I started to dabble in programming probably when I was about 11, writing basic programs. They were all the same, I'm embarrassed to say, but they all followed the pattern of being Monty Python themed and password programs. So, right, the idea would be you would create a simple loop that would ask the person a question over and over again, and until they answered right, it would just keep asking them. And I always went for, classic questions like,
What is the airspeed velocity of an unladen swallow?
And then until you typed in literally African or European, the program would just sit there over and over again asking you endlessly. But again, that was me getting familiar with the idea of iteration, the idea of taking input from a command line and being able to print out to a command line when I was really young, like long before I ever thought about doing this professionally. And then came my first academic exposure to programming, and that was at a small school that I went to for a while. And one of the things that I could do was spend time programming. Although at that point, there weren't teachers that taught programming per se, and I didn't have a lot of oversight. But what I was given was I think, 900 something line program in hard copy on sheets of paper that I could sit there and type each line in, and at the end, I would have a working program. The program that I chose, I went back and looked it up because I was curious, and I believe it was Super Star Trek, which was a basic program that allowed you to play a text-based version of Star Trek. And I briefly looked over the code, and the chances of me at 11 or 12 being able to type in all of those commands on the appropriate lines was vanishingly small. It was never going to happen, and it definitely did. I never got to play Super Star Trek. But what I learned was about the complexity of these things, right? The idea of having 900 lines, which was pages and pages printed out, and having to go through it all and understanding that you, as the user of this thing, are traveling through these code paths, iterating over these loops, traveling through these conditional statements was really eye-opening to me at a time when I was, like all kids, like a sponge, able to absorb and internalize these concepts. So again, this is nurture. This is not nature, right? Maybe nature drove me to this, but my love of Star Trek and my motivation were nurtured. And then in high school, things got really serious.
I guess you could say things are getting pretty serious.
For the first time, I could take a computer science class, which, to my high school's credit, was not something that was super common in the late 90s. And by computer science class, what I really mean is an independent study with a math teacher. But nonetheless, it was an opportunity to really start learning the foundations. I remember then I was programming in C++, and the standard template library, STL, was all the rage. It was brand new, it was being used in AP exams, etc. And for those who aren't familiar, STL was a collection of data structures and algorithms that you could use to make your programs simpler and easier, right? If you have to re-implement every little list and array and vector of things every time you want to code, you're never going to get anywhere or make any progress. So this idea of reusable libraries is very important. And this class provided me a lot of challenges, right? There were a lot of coding assignments. All of a sudden I had direction. I didn't have to make only password programs.
What is your quest?
Or Star Trek programs that someone else made. Now I had a well-defined stated challenge that I could apply my acumen, my understanding to in order to solve that problem and learn how data structures work, how algorithms work. And those challenges were so much fun. I remember being in my father's den with a few of my friends from school working on a computer science problem trying to solve a maze. And for those who aren't familiar, the simplest maze solving algorithm is based on the right turn rule, I believe it's called. But it's the idea that if every time you come to a right turn or come to a dead end, you turn right until you can proceed forwards, you will eventually exhaustively travel throughout the entire maze. And that was cool. Programmed that up, figured out how to create that algorithm, and that was very rewarding. But then working with my friends, we were like, wow, what if we could do this better? What if we could do this other way? And we came up with this much more creative and complicated solution that leveraged recursion and building trees in order to solve the same problem in this very, what felt like, novel and cool way. If I had to pick a moment, that moment there was the moment that kindled in me a true excitement about computer science. The ability to solve problems and come up with these creative and nuanced ways to solve problems that you have is really, really cool. And so that passion continued. And I think, as I alluded to in my video on motivation, the professional world slowly sapped me of that enthusiasm, as I think is common. I don't think this is unique to me. I think that the professional world has a tendency to sap a lot of joy out of a lot of things for a lot of people. But for me, I lost that spark. The excitement that I had solving that maze with recursion did not exist in the world of engineering single sign-on solutions or data integrations. And that's why it was so exciting a few weeks ago when I started a new programming project and refound some of that excitement. Finding ways to solve problems that I cared about, that mattered to me, was refreshing and exciting. To be able to apply this skill that I have to problems that I have was something new and different that I hadn't felt for a while. And so, spoiler alert, the next video is going to be about that. It's going to be about that project because I want to share my process and my thinking because I think that it's kind of an interesting topic. But for now, to get back to the crux of this video, I think that I have always leaned on nature, right? My brain works differently, and that's why I can do these things. But in looking at it, I think that it is the nurture from many different people in my life who pushed me in a direction to engage, learn, and build a foundation on computers that interfaced well with my nature, that ultimately brought me to where I am, which is being pretty okay at programming and enjoying it a great deal. So I think that's it for this one. Next week is going to be a little different. I'm not going to approach it as like a technical tutorial, I don't think. I'm going to talk, hopefully in a way that is accessible to everyone, about the problem-solving approach that I took in order to solve the problem that I was faced with. So anyways, for now, I hope you have a wonderful rest of your week, and I'll see you in the next one. Bye. Not apotamus. Ponderous.